Let's see the definition of a quadrant and the distance formula. So the coordinate axis, so basically the y-axis and the x-axis, right? Y-axis, x-axis, this is the negative x-axis, and this is the positive, negative y-axis. They divide the plane into 4 equal parts, which are called the quadrants. So we have this part, we have this part, we have this part, and we have this part. And basically, quadrant number 1 has all the points with positive x values and positive y values, meaning greater than x values greater than 0 and y values greater than 0 as well. This point, the center point, basically it has x values of 0 and a y value of 0, right? So it's the center point of all the x's. So if you look at this origin over here, all values to the right of the origin have positive x values. All values above the origin have positive y values. All values to the left of the origin have negative x values. All values below the origin have negative y values. So quadrant 1 has positive x and positive y values, which means that it is above the origin and to the right of the origin, which means it's this one, this quadrant. Quadrant 2 has negative x values but positive y values, which means positive y values means it is above the origin, and negative x values mean it's to the left of the origin, which means it's this quadrant. Quadrant 3 has negative x values and negative y values. So negative x values means it's to the left of the origin, and negative y values means it's below the origin, which means it's this one. And quadrant 4 means positive y values and it is negative y values. That's an error. And it has positive x values. Positive x values means it's to the right of the origin. Negative y values means it's below the origin, which means this one is quadrant number 4. Now we've divided all the 4 quadrants. Let's see how you can represent a point P as an ordered pair in this form. So if you draw the axis again, right? Y, x, and negative y. So you have this point P over here, right? The x value corresponding to this point P is -5, and the y value is, let's say, +7. You can represent this P as this, -5, 7. This is how you can represent a point P as an ordered pair. Okay? Now, let's see the distance formula. Basically, if you have a point A with x1 as its x value, right, and y1 as its y value, a point B with x2 as its x value and y2 as its y value. Now you can see we're representing them as ordered pairs. You can find the distance between point A and point B using this formula, which is derived from the Pythagorean theorem, right? So just to clear it out how that happened, you have this positive y axis, you have this positive x axis, the negative x axis, and the negative y axis. Say you have this point here as point A, and it has the x value, right, of say this is x1 and this is y1, right? And say you have, let's say, this point B over here, right? And this is x2 and this is y2. Now you can draw a line between them. This will be the distance between A and B, right? This line that connects them. And you can draw this as a right angle triangle like this. So this distance between AB is the hypotenuse of the right angle triangle. The difference between its y values is this one here, right? And this will be the opposite side, right? And the difference between the x values will be the adjacent. So if you apply the Pythagorean theorem on it, the opposite side is clearly y2 minus y1, right? So y2 minus y1 whole square plus the adjacent, which is x2 minus x1, right? x2 minus x1 whole square is equal to the hypotenuse, right? Which is what we're trying to find. That will be AB modulus. And that is where, whole square, by the way. Sorry. And if you take the under root over here, you can cancel this out. And that's how you got this distance formula, right? So yeah, that's it.